Hello viewers. Welcome back. In this video, we will discuss a recent Streamflow forecasting paper. Let's start the discussion. Hey ML, have you heard about the recent research on Streamflow forecasts?
No, what's it about?
Well, Streamflow forecasts are really important for managing water resources, mitigating drought and flood effects, and developing climate-smart infrastructure in industries. But many regions globally have limited streamflow observations, which makes it challenging to have evidence-based management strategies.
That's a significant issue. Is there a solution proposed in the research?
Yes, the researchers propose an attention-based domain adaptation streamflow forecaster for data-sparse regions. They use a deep learning framework and leverage the hydrological characteristics of a data-rich source domain to make effective 24-hour lead time streamflow predictions in a limited target domain.
Interesting. So, how does their approach work?
They employ domain adaptation techniques within their deep learning framework. The model is trained to simultaneously predict streamflow and distinguish between the two domains using an adversarial method. This allows them to transfer knowledge from the data-rich domain to improve streamflow predictions in the data-sparse domain.
That sounds innovative. Did they compare their approach with existing models?
Yes, they conducted experiments comparing their model with baseline cross-domain forecasting models. The results showed that their approach outperformed the other models in terms of 24-hour lead time streamflow forecasting.
That's impressive. I can see how accurate streamflow forecasts would be crucial, especially with the changing climate affecting precipitation patterns.
Absolutely. Climate change can alter the timing and amount of precipitation, which directly impacts streamflow. With more frequent and severe weather events like droughts and floods, accurate streamflow forecasts become even more critical for effective water resource management.
Right. Water resource management is already challenging in many regions. How does this research address that?
The authors highlight that access to clean water is often a challenge, and sustainable water resource management is vital for human health, food security, and economic development. They believe that their climate-smart streamflow forecasts can play a crucial role in these regions by improving water resource management and supporting adaptation to changing conditions.
That's commendable. Did they provide any specific results to support their approach?
Yes, they tested their model on the Camel-CL region, where around 10% of the streamflow data was missing. Their model achieved better generalization with an average Nash-Sutcliffe efficiency, NSE, score of 0.37, compared to the transfer learning LSTM, 0.32 NSE, and GRU, 0.11 NSE, models.
Those results demonstrate the effectiveness of their approach. It seems like this research has practical implications for regions with limited streamflow data.
Exactly. It offers a valuable tool for improving streamflow forecasts and facilitating better water resource management in data-sparse regions.
Thanks for sharing this information. It's exciting to see how advancements in deep learning and domain adaptation can address such critical challenges.
You're welcome. It's definitely promising to see how technology can help us tackle important issues like water resource management and climate adaptation.